Okay, so let us continue from where we left. Last time, what we saw was we saw how the Hoffman coding problem works, what is its input, what is its output, and what we mean by encoding process and what we mean by decoding process. And we saw all these steps as well, like how this tree was constructed, how this table was initialized. This table is an input table, and most probably you'll have an output table with this tree and this codes. So now as an output, what you'll have is you'll have this table where for each character, given its frequency or weight, we generate a binary code for it. And here when we generate a binary code for this, these codes are also called as variable and binary codes. They are some another alternative to Hoffman binary codes, which might ask you to generate a fixed length codes. So that's a different logic, but we will only look at variable length binary codes. And in last lecture, we did also look at how we have generated this tree. uh, what was the condition to select the initial nodes, and what would be the next iteration, what node would be selected, and when would this entire process end. So as a quick recap, what we have done is we have a table where we have the characters and its frequencies. What we do is we always take a characters with minimal frequency, for example I with 1 and z with 2, and we merge them and we form a new internal node. And we the internal node has a frequency which is addition of its child nodes, so we will call it as cumulative frequency for it. And once we have this, we mark the earlier two nodes as visited. We mark them as visited, and whatever the new node was formed, we add that into the table. So next time what we do, we repeat the same process. We select next to minimum, and this next to minimum can be the two leaf nodes. Let us call it as data nodes or internal nodes. This we'll call it as internal nodes. We'll call it as data nodes. So the next to minimum could be two internal nodes, or it could be two data nodes, or either of that. It means one could be internal, for example one could be internal and another could be data leaf node. So we do combine them, we create another node, and this process keeps on repeating. This process keeps on repeating till I only have one unvisited node in this entire table. So we keep on creating node, and we create that. And every time when we are creating a node, if you look at internal node, it has two siblings. Rather than saying siblings, it has two childs, left and right child. So these let you navigate across the tree. And in the end, when you want to find out the actual binary code, what you do is you start at root, and for each character you have a. Till you find a in this tree, you will navigate to it. And the moment you find this node a, whatever the navigation you have done to arrive at this node location a, this navigation defines the binary code. We assign 1 for right branch and 0 for left. So that's why the binary code for A is 1 0. And if you look at I, it should be 0 1 0 0. The same appears here. So today what we need to do is we need to write a program for this exactly on the same simulation lines. I don't want to do any additional n square sorting or anything something. So we need to write a Python program to get this binary codes out of this input tree. Okay, so let me switch to PyCharm editor. So before we switch to PyCharm editor, like I would like to get some opinion around this program. What do you think? Will this program be hard or it can be easily implemented? We have already seen some of the implementations of earlier tree-based approaches. So here, what do you think? Will it be difficult or will it be okay? We can implement. Or what data structure you recommend to store this input table? Give me a minute. PyCharm window is loading. Okay. Okay. Do you see the PyCharm window? Let me know if you look at you see the PyCharm window. Okay. So now what we need is we need to represent the table and we need to get that first we need to figure out how do I represent the input. Remember, it's very important that whenever you want to represent the input, uh, if you badly represent input, that might complicate your algorithm. If you represent your input with reference to some of the Python's built-in available algorithms and some built-in algorithm or data structures, it would be quite easier for you to write program on that. So many developers they fail to understand this, but remember a proper and good way to represent input will make your program far more easier to implement or execute. So how do you suggest that whatever the table which I have, like I have this input, like okay, character and frequency. What do you think? Like I can, how you think that I should represent this input as a dictionary, as a set, or a tuple, or as a any some custom class or some another kind? What do you represent? Can I get your responses for that? So what do you think is a good way to represent input here? Remember that here we also have to form a tree. And can anyone recall any Python implementation which can let me create a tree? I need to create a tree because unless you create a tree, you cannot get this Hoffman codes. So how do you think that we can form a tree? How should you represent the input? And once I create a tree, I need to even navigate the tree as well. I hope you recall that in order, pre-order, post-order traversal. We may need a similar traversal algorithm for here to get the binary codes. So as a quick, what I'll do is I'll create a class called as node. So let me define a class node, and inside a class node, I will create few instance variables which will then define what a specific node is. For example, when you talk about this node, then I need to always have init. So in init, I'll define here few parameters. For example, the first one would be the character for which I am working on, and the second would be the frequency. Third, okay, so I'm now trying to represent one node in a tree. So the data I will be passing to it is the character and the frequency. Then if I have a character and a frequency, I have two types of node, one as internal, one as a leaf nodes. So leaf nodes are the one for which I need to calculate the binary codes. Internal nodes are slightly different. So I'll also take something called as node underscore type. and every node has two pointers within it, left pointer and right pointer. So let me call it as left underscore PTR, and let me have something called as right underscore PTR. Now whenever I get them, I need to initialize them. So character, frequency, node type, left pointer and right pointer. These I have to initialize. Character, let's call them self dot character. Then they start becoming the variables of this class objects. Okay, so this will be the first node creation. So every node has a character, the frequency, the node type, left pointer and right pointer. Then once I have this, and if I want to print this, okay, now this is a class, right? This is done. Now if I want to represent the input, if I want to represent input, I need to create a list of nodes, right? So to create a list of nodes, let me do one thing. Let us call, okay, let us create a list called as node list, which will contain my input, which will contain the input. So when you have this, you can call, you need to add an input to this node list dot append. So I am maintaining the input as a list of nodes. Each node is one input, leaf nodes. From this nodes, I'll be constructing my tree. So here I'll add a new node. What is the first thing? The first thing is a character. What was the first character I had? Can someone let me know what we had initialized? Let me go back to that. The first node is A with value 10. So the first node is A, frequency is 10. What is node type? Leaf node. First is leaf node. And initially the left pointer and right pointers for these nodes will be nothing. So if you look at the tree, all leaf nodes have no left child or right child. So these pointers will be null, and in Python we use none to refer null. Okay, this is one node. Likewise, I need to add multiple nodes. I think how many nodes on input we have? A, and after that we have a B, input as 4. Okay. After that I have I, input as 1, Y 12. So that I had Y, input was 12, and then Z as 2, Z as 2. I think one more node I left. What was C? C is equal to 6. Okay, so now your input list forms my input, and I need to now construct all internal trees for this set of nodes. Now to construct the tree, what was our approach? Our approach was to get minimum among these two. Every time I need to get two minimum out of this, then create a node. Once I create a, once I get a minimum, that should be removed from this list and a new node should be added to it. Whatever the new node which I'll be forming by combining these two, that node type will be something called as internal. It won't be leaf node. So that I'll be adding it to a list. And when I add that to a list, what I do? Once again, I take two minimum. I remove from this node list, and then I add a new node. And after that, from that I node next two minimum. What do you think is the best data structure to use that kind of behavior? Can you suggest? We have already used that data structure, which will let me which lets me remove the minimum elements in O of log n, and I can dynamically add any number of elements to it in runtime. Still, it always gives me minimum elements. What is that data structure that I need to use here, which works on that, which gives me minimum in O of log n, and I can dynamically add or remove element, and still every time I call minimum, it will be giving me the minimum elements. What is the data structure I need to use here? Can I get a response in chat window? We already used it. Yeah, it is heap queue. Yeah, we use min heap. Yeah, that's what we exactly use that. So we need min heap. Now, we need to use min heap, that's right. But the problem is when I create a min heap, I need to define how these elements of that min heap are compared. So when I had list of numbers, for example, when I have 2, 3, 4, 5, here the heap P5 process was in knowledge of knowing which is less and which is greater, because it is natural numbers, they are numbers and it knows that. But now here I have nodes, node 1, node 2, some nodes. So how do I tell my heapify which node is less and which node is greater one? Is there any function here which can let me compare the nodes? And if I'm not wrong, we have already discussed somewhere, but I'll just let you know what it is. So if I want to define some ordering on the objects of class node, if I'm not wrong, we saw a student class object, right? I wanted to define student S1 less than or equal to S2. By default, it says to S1 and S2 are not comparable. If I want to define which is less and which is greater, I need to override a small method here. And I used to call those methods as magic methods. Can anyone tell me what is the name of magic methods I need to override here, which will define the ordering for this? I need to just tell what is less and what is greater. Rather than telling greater or not, I need to just define the less than behavior. What would be that magic method? That magic method is nothing but it's called as LT, which defines less than or equal to. So one is the current object, other is another object passed. So you need to define how you compare one node object to other one. So what you need to do here in this case, what parameter I need to compare in order to decide the order? I always go on the frequency. So I'll just return self dot frequency. I'll return whatever the value I get for self dot compared with other dot frequency. The other is other object. So whatever you have here other, this object frequency, whatever it returns, that is returned. So I have overridden the default natural. So remember, whenever you want to use heap, min heap, you have to make sure this is defined. Specifically when you want to heapify list of some class objects. So here I want to heapify the list of class objects. So I am making sure that I have overridden LT. This is one of the magic method in the Python. Okay. So now I have a node list. What I'll do is I'll heapify it. How do I heapify it? What you need to do is I need to import heap queue. After importing heap queue, now I can heapify. So how do I heapify? Heap queue dot heapify. I need to pass the node list. This will heapify the entire node list. After heapifying the entire node list, now heapify the node list. So now I have heapified that. Once I have created a heap out of this list, what I need to do? I need to start my actual algorithm. What it does? Remove two elements from this, create an internal node, add that internal node to heapify. And I need to repeat this process till I end up having only one node in this entire heap. So what would be the loop? I'll use a while loop. While length of node list, for length of node list, is as long as the length of node list is greater than 1, I will be running my loop. So inside my loop, what I'll be doing? Let me create min node underscore 1 is equal to get first minimum from this. How do you get the minimum here? So heap q dot heap pop it from the heapified list representation. This will be the first minimum node, and this will be the second minimum node, which I'll store in the variable min heap underscore node 2. Right? Once I get this both, what I need to create? I need to create an internal node. So let me create internal node. Internal node is equal to, tell me what will be internal node? Node, it will be node. And what character it will include? What is the character I am including in this internal node? Can you get that? So in our case, I was just adding that as an comma node, right? So let me do one thing. So what I do is min node 1 plus min node 2. So what I'm the character is min node dot. Let me just close it. So min node dot character plus min node 2 dot character. So I am getting that character. The first parameter is a character. What is second parameter? Frequency. The frequency is what? The sum of these two. So what I had min nodes character 1 dot frequency, and the second min nodes frequency. Then after frequency, what I have added? The node type. What will be the node type? I will now create another node type called as internal node. After creating internal node type, then I have left pointer and right pointer. So where should the left pointer point? The left pointer should point to min node 1, and right pointer should point to min node 2. Okay, so this marks the creation of internal node. Once I form the internal node, what the process I need to do? I need to add this internal node back into the min heap. So how do I do that? Heap q dot heap push a new node, push a new node into the already heapified list. And what will be that new node? This internal node. So I'll keep on repeating this process till I end up with node list being having only one node in that. Okay, so far clear. I hope you understood what exactly we have been doing. That understood this? Okay. Can I get a comment? Have you understood till this point? So this marks the end of algorithm actually. So once you form this tree, what's the next remaining thing? The next remaining thing is, say you have formed the tree, but is it the end of my algorithm? No, my algorithm has to actually output the binary codes for each character. So now to get the binary codes for each character, what I'll do is I'll create a small dictionary called as Huffman codes. Create a dictionary called as Huffman code. Now, when you have this dictionary Huffman codes, I need to generate Huffman codes in this format. For example, the key will be the character, and the code will be the set of binary strings for the specific character. So if tree is formed, and if I want to uh, what I am doing here, the tree is formed. Now I need to generate a binary codes for this. So can you tell me how I can do that? I need to traverse a tree. Now, when I'm saying tree, you might be asking, sir, where is tree formed? Remember, this process will form the tree. This process will form the tree. So whenever I'm creating internal node, this node is pointing to these two objects. And when I say min node 1 and min node 2, am I passing the object or am I passing the reference? Remember, here I am passing the reference. I am not actually passing the objects. Whenever we have class and objects, For example, I create a class student. When I say s1 is equal to student some value, and if I say s1 is equal to s2, s1 and s2 both are pointing to the same object. So here I am using this references as a pointers. So here in this process, I am creating a tree internally. I am creating a tree, and the whatever the end node which is left inside the node list. So when you come out of this, the node list will contain only one node. That node will be the root node. So considering and holding that root node, you have to traverse the entire chain of the tree. And while traversing, you need to keep note of left side, left branch, right branch. So that the moment you reach a leaf node, you will output all 0, 1, 0, 1s which you have gathered that. And that marks the binary code for that specific character. So what I want, let me tell you how it works. So I need to traverse the tree. Now for time being, I'll just switch to our earlier diagram. Okay, so assume that this node was formed. It is now formed, right? Now I want to print a binary code for let's say I want to print. Okay, rather than going for each character, what I do is I start with this root node. What I do is I traverse to left, and when I'm traversing the left, I note of this 0. Then I get to here. I'll see what if it is. Is it internal node or leaf node? It is internal node, so I will move to the left. When I move to the left, I have taken note of these two zeros, and I'll check what is the node type. Is it internal or a leaf node? It is not internal, it's a leaf node. So there is no point in going to left or right. The moment I reach this leaf node, whatever this 0, 0, 0s I have stored, that will become the binary code of this character. So the moment I encounter a leaf node, I just print my all the navigation list 0, 0 and Z, right? So now once I have reached to this leaf node, what I do? I go back. I now explore its right branch. When I explore the right branch, I'll note of this one. I'll see is it internal node or leaf node? It is internal node. So I'll once again go to the left. When I go to left, once again I'll check whether it is internal node or leaf node. Then I'll go to the left. Internal leaf node. If I get a leaf node, whatever the trace I've been maintaining, just output it. Then go back to this, explore right branch. So all the earlier one plus this new one, it is output for Z. Then I go back, then I get to B, then I come back, then I explore this, then I explore the right side, then I go for it is a leaf node. I print all this, go back, I have this node and I print the codes for this. So if you look at this, it is almost an in-order traversal. So do you agree that it is an in-order traversal of the tree? What is your response? Do you think we are doing in-order traversal, or are we doing pre-order, post-order, or something else? What kind of traversal of tree it is this? The logic which we right now saw. Yeah, it is in order traversal, right? So effectively, or in other words, I need to write a in order traversal for this tree. Okay. So okay, the discussion and the logic which we had right now, this might give you a picture that this code will be very complex. But remember, it is not complex. I can write a recursive code very easily for this. So let me write that. Okay. So this might be little tricky for everyone, but okay, let us try to write. So what I do is, since I want to do an in order traversal, okay, let me switch back to PyCharm. Window. Okay, hope you see my PyCharm screen. Okay, whatever we discussed there, here I have come to the point where we left. What I need in order traversal. And if you recall, the in order, pre-order, and post-order, the most easiest and small way to write them is to recursive one. So what I'll do is I'll create a method, and let me call it as method as compute underscore Huffman codes. Okay. To this, I'll be providing some node. Let me call it as node. And every time I get a node to it, I need to just compute the string. Now what I will do is, along with node, I'll also have something called as code string. So this code string will keep track of my left and right. So whenever I move to left, I will append 0. Whenever I move to right, I will append 1. So accordingly, this code string will have all my history of traversal from root to left, right, and left, right. And in recursion, whenever I go back to upper node after a call returns, I will still have what was my earlier code string. So it might look to you like it is almost acting like a stack here. Now it is up to you how you can use any other data structure, but I find this little bit simpler than using a stack. So I just take a code string, and whenever I come into this loop, what's the first thing I check? The first thing I check is if a node is internal node or a leaf node, right? So what I'll do, node dot node type, if it is not equal to, if it is not equal to leaf node, then I will decide to move to left. I need to move to left and right. So if I want to move to the left, what I need to do, compute Huffman codes. When I say left, what is the new node? Node dot left pointer. And what will be the code string? The code string will contain whatever the code string which I have passed, under the code string I have passed, plus it will have a 0. I'll append a 0 to it, right? Likewise, when I go to right, what I will be using? I'll be using right pointer, but now instead of appending 0, I'll append 1. Okay. So this is what if I go for if. If the node which I'm moving, if it is not leaf node and if it is internal node, if it is internal node, what I do here? Can you tell me if it is not internal node, what should I do here? Just think on and let me know your response in chat window. Okay. Can I get your responses? Just give me a minute. Just give me a minute. But by the time I come back, just think of your response and type it in chat window. Just have some water. Can you tell me what should I do in else? If the node type is leaf, I'm moving to this, and if I encounter internal leaf node, what should I be doing? If I the moment if I enter the non-leaf node, what I do is I directly have to output the code. The moment I need a leaf node, I just stop the edit point, right? And I just return from that. So at that time, I'll just add to this dictionary with a key as node dot character. The moment I reach, I'm creating a key in this dictionary. See, this is a dictionary here. To this dictionary, I'll add this node character, and what it will contain? It will contain the code string obtained till now. Till you reach to that leaf node, whatever the code string was there, that you will just add it to this Huffman code as a tree here. So that completes this method. That's it. We don't need anything else. That's it for this compute Huffman codes. Okay. Once this is done, let me check just an input. So we have heap queue class node. We have overridden this. We have a node list. We did the heapify for it. Then I was moving to this all codes. Then probably this is for, I take it for output. For output, I use Huffman code, and this is for in-order traversal, in-order traversal of the computed tree. In-order traversal of computed tree. This is for in-order traversal. Then once I'm done with this, what I will do is we'll execute this code. So what will be the input? How should I execute this? We have okay, the input is given, it executes that. I need to just call this compute to get the Huffman codes. So what will be the compute for Huffman codes? What is a root node? The root node is always the first node of this heapify when you're heapifying this. So how do you get the first node of this? As you know, heapify is nothing but it's a list based representation. I will pass is first node. What is the end node which remain? And I'll pass a blank code string which gets created with this. And okay, once it is done, I'll print the dictionary, which it should have Huffman codes within that. So this should print the Huffman codes. Okay, let me execute and see if we have any errors or if we are getting a right output, or let us debug if we do not get a right output. So let me run this. Okay, I got some output. Okay, so I got this output as a code for this. Is it right? Do you think this is right? Uh, okay, let me do a green or give me a one more minute. I'll just take you to the earlier screen. Okay. Uh, I'll come back to this, and here I will put this on. Okay, what do you think? Are the codes computed right as per this logic? Can you compare and tell me if you have computed right codes? Did we compute right codes? Okay. Yeah, I think they are right. Now, can anyone else give me some another example? We'll try out. See, every time if one input works, it is not the right thing that we always get the right output. Let us try any other. Can someone search for any other input? For example, uh, let me get a code. For example, if I have a Huffman code with a frequency to, let me create something. I'll create an input. Okay, let me create this. Oh my God. No, what I want to do is I want to create a characters for this. For example, if I have, okay, I think this will take a time. I'll just add that into one small text box, and I'll, for example, if I A with 45, the frequency of A as 45, A as 45, and B as 13, B as 13, C as 12, C as 12, D as, let's take the frequency of D as 16, and E, let me just take all the notes in serial, E as 9, and F as 5. Okay, so what I want, I'll give you, say, let's say one or, okay, so let me give you, it's 10, right? Let me give you 10 minutes or 5 minutes. Can you compute binary codes for this? You can take a pen and paper at your side. Can you compute the codes for this? And that we will compare with what our program gives. Can you compute for this? So just compute the binary codes for the given input. I'll also paste that in chat window, and we will compare it with our my program run, and we'll see if our generated binary codes match with the program generated binary codes. If they match, then most probably we have a correct working program. So I'll give you 5 minutes, or okay, I'll give you 5 minutes. I think in 5 minutes you should be able to form this tree. That would be also good practice to solve it, because in theory examination you will be asked to write this tree in your as an answer. So that's why I want you to generate this tree for your side. So I'll put a timer for 5 minutes. Then we will see what binary codes you're generating that. Okay, just take 5 minutes and give me the binary codes for the given input. I have already put that input in the chat window. So were you able to compute the Huffman codes for this? Can you type Huffman code for each node A, B, C, D, E, F? Start typing that in a chat window, or if you need more time, that's fine. So by the time you type that, I will convert this input into my PyCharm Python code. Okay, hope you can see how I have set the input. I have called this as sample input 1, and now I'm calling it as sample input 2. Just compare A45, B13, B13, C12, D16, E9, F5. So for this, if I execute, let us see what codes it will get. But before that, I'll see what response. I think Gurnath has already computed what he's saying. A will get 0, D will get 10, B 110, C 110, F triple 10, E will be all 111. Means you're saying E will be at a very extreme right. Okay. So any other computation? Any other student computed that, or if he agrees to this, what Gurunath has pasted here, let me know if you're fine with what he has computed. For example, let me just put this here. Okay, let go through this and let me know if your matches, or if there is, if you say it is right, I'll execute the program. Can I get any other response? I want one or more students to solve it so that we can verify the computed answer. Any other student? Or you can at least tell me if your output matches with the output of the currently which I have highlighted here. Okay. C, you are saying it as 110, F as 1110. So he is making a correction. Correction he is making is C, he wants to change it to 110, and F, as the correction is F in that he now makes to 1110. Okay, you're saying E and F will be at this node. Okay, have you solved? Or you want me to solve? Let me be very clear, be responsive. Like you have solved, get the responses. Remember, right or wrong answer doesn't matter. You need more time, that's why I'm fine to give you more time. But I want you to compute. So initially what I'll have, the minimum is E and F. Then the addition of this 9 plus 5 is 14. 14 will be 14. After that 12 and 13. And then after that it would be other combinations. Okay, let me execute. I'm not sure what other students are doing. Okay. Kedar has said, Kedar is saying E will be 110. E will be 110. And F he is saying is 1101. F he is saying is 1101. Mm, okay. What Rahul is saying is whatever the Guru has computed, they are right. Okay, so okay, let me execute it, and then if they differ, then we'll see. So I'm executing this. Okay, I have computed this. Now this is what I get. A0, yes, this is match. C 100. C I'm getting as 100. B 101. F 110. E 1101. D as 111. Either this should be wrong or our output should be wrong. Okay, let us do one thing. We'll solve it. We'll solve it. Mm, okay. If this is the input for us, we will solve it. Let me know if you see my screen. Let me create few shapes first here. And if meantime if someone is solving, let me know if you agree with the what program is generated. Okay, so this is the input here. I'll drag the input to this position. I'll increase the size of it. Okay, what will the first two minimum nodes? The first two minimum nodes are E and F. So I'll have E and F. What is E? E's value is E and F. So I always try to keep lesser values to the left. So 5 and 9. So when we both merge it, I get an internal node, and this node will now have these two values. And what will be the effective frequency of this here? 5 plus 9. What is 5 plus 9? 14. So 14 will be added to this node list. I'm not writing characters, just I'm adding the addition. So you will have one more value here, which is 14, and E and F, you are tracking it because I've explored that. Now what are minimum? 12 and 13. So 12 and 13 are minimum from this. So I'll have two more nodes. Let me keep some, later we will move this. What are those? It is 12 and 13. 12 and 13, they together will form one more internal node. So it will be here, it will be here. What is sum of these two? It is 25. So 12 and 13, these two I have explored that. And I have added another node with value 25. Fine, so far clear? So far clear? Then after adding 25, what are next two minimum? What are next two minimum here? Next two minimum will be 14 and 16. So 14 will be left. This will become a left. 14 and 16. 16 is a leaf node, so I'll add a 16 here. This will be 16, and they both together will form a tree. So what the sum of this is 30, 30, and what I have exhausted, this I have explored 14 and 16, and I am adding another new node 30. Now, what are minimum? The minimum are, I think, 25 and 30. The minimum are 25 and 30. So I'll keep 25 and 30, both will be working and both will form a new internal node. 25 and 30. What's the sum? What's the sum I'm getting? 25 and 30. 55. So I'll add another node 55 and I've explored 25 and 30. What are minimum? Now this data node 45 and that 45 is less than 55, so I'll try to keep a to the right of this. It will be 45 and they both together will form an internal node. So what value I'll get? 90. Is it 100? Okay, so this is the tree which I'll be getting. So if I get this tree and if I put this values 0, I think I need not do this. Let us save some time. I can put zeros and ones. Okay, so do you agree with this tree? Or you think I've done any? Okay, so what I'll do is I'll just keep on putting this left right 0, and where else I'll put 0 here. Left branch is 0. This is left branch is 0. Where else? This is left, and this is left. Okay, I hope I covered all lefts. Now I'll cover left rights. I'll call it as 1, 1, and 1. This is one more one, and the last one. Okay, I covered 0, 1, 0, 1, 0, 1, 0, 1. Okay, now let us form the codes for this. So if I want the code, okay, A. Okay, well, let me forget. So A, where is A? A means 45. So this was A node. So it is 0. A will get code as 0. And if I go to this 12, what is this 12? 1, 0, 0. C will get C. This is C node, right? 1, 0, 0. D. What was the original frequency of D is 16. Where is 16 in this loop? Here it is D. So it is 1, 1, 1. 1, 1, 1. After D, A, B, we'll see B. Where is B? B means original is 13. Where is 13 here? Here. 13 means 1, 0, 1. 1, 0, 1. A, B, C, D, E. Where is E? Original means 9. Where is 9 here? Here it is 9. So 1, 1, 0, 1. So it is 1, 1, 0, 1. And then we have F. What is original value of F? 5. Where is 5 here? So 1, 1, 0, 0. 1, 1, 0, 0. So have I covered all this? A, B, C, D, E, F. Okay. Now I'll get that output from the window here. Okay. This is the output which I got. Is it same? What it is? A0. Okay. C100, C100, B101, B101, F110, F110, E1101, D111. Okay. This matches with our output. Okay, but okay, as Gurnath has said, see, I appreciate your effort. I'm not, I think everyone should take a good chance to appreciate Gurnath. He has solved it. See, I'm not saying that he is wrong or that. He has solved it and I appreciate a lot. So, those who appreciate Guru, you can type Guru OP. I think all those who are gamers will understand. You can type Guru OP. If he has, if you think, I at least appreciate. I'll type this one. He has done that, I type that. Yeah. Okay, so I hope you have understood how exactly I have solved this, how we are doing that. I think our program 2 works fine. So what I will do is, I will upload this program. I have recorded this Huffman entire series, the earlier lecture and this lecture. I'll upload this recorded sessions. I'll upload the program. And one thing I am expecting from you is, given this string back, for example, if I give 1110 or something, how would you decode that? Decoding that string back into that. I'll share the logic. What you will have to do is, if I get some string, for example, let us suppose I am giving you input as 1100, 1100, and I'm giving you output as 111. So when you want to decode, what you will do is, you will compare this. For example, 1, 1, 0, 0. So what we do is, we traverse this tree. The moment I get 1, I move to the right. I get right, I move to this. So when I get 0, I get 0. And when I get 0, I get move this. So what I do is, 1. I'll check, is it leaf node, internal node, internal node. So I'll scan next character. Internal node or internal node. So 0 left. Internal node, yes, internal node. When I go to 0, is it internal node? No, it is not. It is leaf. It means that this is character 5. Means 5. 5 means it is 5. So you will get F. Once you get F, you will stop that. And next character, when you start from for this one, you will again start with root node 1 internal node, then move to right. Next character 1 internal node, move to right. Then is it internal? No, it is not internal. It is leaf. Stop. And whatever the character you have for 16, what is that 16 here? You will print D. Okay. So that's how we do a decoding one. So I will expect you to solve decoding of this, and I will add this as one assignment. Okay, the one assignment in your entire curriculum would be, I'll give you this Huffman code and that, and I'm asking you to write a program to decode that string. Fine. And also I'll share the assignment list so you can spend time on that. Soon you will get a assignment list in 1 or 2 days. So it's almost 10:30. Just one last. Have you understood what we have solved? If you haven't, if you have partially, go through all lecture recordings. I'll upload it to YouTube. Go through that and hope you have understood this. Specifically, I want you to understand the way we wrote the program. See, our program was very simple just because I was able to represent that in a proper format. So remember, I'm not saying that you should always get this order. So slowly, when you keep on practicing program and program, you will develop the skills to how to implement program, what logic it is, how I can use and all that. I'm not expecting that you will get it today itself, but yeah, you will get it by practicing, by solving various problems. Slowly, you will get that. So whenever you see a problem, don't directly jump to coding. Think about that problem, how I can solve, what should be the one. You will have a rough logic going in your mind. Then once you have that rough logic going in your mind, then you can easily start writing the program. Fine with this? Any questions? And can you comment? Have you understood or not? Yes or no? Can you come? Have you? Okay. Fine. So others, you can watch the recording, you can discuss with the students. Then if you have still not understood, let me know. We will discuss in the Telegram group. I hope you have understood. This see, the algorithm looks complex, code looks complex, but if you have understood, that's very fairly simple. If you see here, this is the only code which I have wrote. This 3 lines and this two. That's it. So when we started learning heap queue, you might have not realized how important this is. But if you look at consistently, we have been using heap queue for last for 4 to 5 algorithms. That's the beauty of Python. That's why I say the Python is far more easier for algorithm developers to write basic codes. Okay, so that's it for this lecture, and I'll upload them. And as an assignment, I want you to write a decoding one. Let us see, try that. If you have any difficulty, discuss that. We'll see how to solve that. If not, if majority of students have difficulty in that, then we'll see how to write that decoding program. Now, decoding program is fairly simple. You have to just go through that codes, or you have to compare dictionary codes. I will leave it to your creativity, how you will solve that. But remember, what are the complexity which you have done? What do you think the complexity of this it is? The complexity of entire Huffman will be n log n. The n log n, the max complexity is to just sort these nodes in this. The heapifying of this input nodes is the only complex operation, and the heapify is n log n. So the complexity of Huffman code is O of n log n. And here, if you look at that, I am not exceeding or I'm not implementing any n square algorithm. This program's complexity is also n log n. So whatever the heapify which you have called here, where it is here, this itself is O of n log n. N log n. Here, whatever you are doing, this will be at max n operations. That's it. At max n op, it would be in proportional to n. You might say that every time I'm adding a new node, but see, you will every time you are removing 2 element, adding one, removing 2, adding one. So you will end up with almost n scans. So O of n plus n log n is higher. The overall complexity drops to n log n. And we are not violating, we are not using very heavy for loops or that. Just we are relying on standard implementations. This should work. And if you take this additional complexity, if it is n, loop executes n, and this pushing this internal node operation is log n operation. This is also log n. This is log n. So at max, this entire loop n times log n. So it will not exceed more than n log n. So it is also will be O of n log n. So the overall complexity will be n log n plus n log n, 2n log n, which is n log n. The entire output comes down to O of n log n. That will be entire. Okay, so that's it for this lecture. I'll upload them, go through that. Any issues, any queries, we'll discuss in the Telegram group. And I think this is, I doubt if Friday's lecture will be conducted or not. You may be having some Diwali, but I'm not sure right now. You will get communication from class coordinator. I think 13th. When is Diwali? 13th or 14th? Diwali. Maybe I think it's 14th, I guess. I'm not sure what exactly. But hopefully, I think 13th may be a holiday. But your class coordinator will confirm that. So, anyways, I'm not sure if 13th is holiday, then I won't be we won't be having a lecture. If it isn't, I'll see what to manage, but I don't want to disturb you during this Diwali period. So, anyways, that's it for this lecture, and wish you a happy Diwali and make sure you celebrate it with proper care. Okay, so if you have not questions, that's fine, and we can end this lecture. We'll see when once we meet next time.